to the next flap of our foldable. On the little tab next to the number 2 under the dashed line, you should write in multiplying rational expressions, which is the same as this heading here. Multiplying rational expressions. Our steps are the same as the steps from the last one, from simplifying rational expressions. Those steps are first to factor, if possible. Then, step 2, you're going to set the denominators equal to 0 to find excluded values. And lastly, you are going to cancel to simplify. Just as a really quick refresher, we're going to look at this basic example, which is multiplying rational expressions, or we call these multiplying fractions. It's going to work the same way as multiplying fractions work. So on our multiplying fractions example, we have nothing that's going to create a 0 in the denominator, so we can skip step 2. There's nothing that can be factored because they're all single terms, so we can skip step 1. So really we're just looking at step 3, that cancel to simplify. When we're looking at this, we know that 5 and 10 are both divisible by 5. So we can cancel out 5 by dividing it by 5 and getting 1. Cancel 10 by dividing by 5 and we get 2. Then, with our fractions, we just multiply straight across. 2 times 2, it gives me 4. And 1 times 7 just gives me 7. So my answer here is just 4/7. And this basic principle is the same that we're going to use for these examples of multiplying rational expressions. On this first one, there is nothing to factor because each part of this fraction, it's not letting me just point, but each part of this fraction, so this piece, this piece, this piece, this piece, those are all single terms. So there's nothing that we could factor out of those. They're already individual terms. So we can skip our first step and go straight to our second step where we are looking at our denominators to see what excluded values we would have. We need to break this up because we don't want to set two variables equal to 0. We're not going to be able to solve that. So we can set it up so that we have 2x equals 0 and y squared equals 0. Because really, when we have variables right next to each other, they're being multiplied. We can also say 4y equals 0 because we want to check both fractions. Yes, it's going to be a little redundant. That's okay for this point right now. Solve. And we get x equals 0 and y equals 0 twice. So then we can start to cancel. This is the part that I need you to make sure that you're watching carefully. Feel free to rewind the video if you need to, because this is probably where you're going to get a little lost for some of these numbers. It's not hard, it just gets a little sloppy. So let's start with the numbers. I know 8 can divide by 2, so I'm going to cancel those. That 2 becomes 1, 8 becomes 4, because when I divide 8 by 2, I get 4. Now my 4 can cancel with this 4. And that 4 is going to become a 1. There's no other numbers that I can cancel, so now I move into my variables. I have an x here and an x cubed here. So that x cubed is going to become x squared, and my x in my denominator is going to cancel completely. There's no other x's in my denominator. I can move on to my y. I have a plain y here and a plain y here, so I'm going to cancel those out. It's an even trade. And then I have a y squared and a y cubed. So I'm going to make that y cubed into a y to the first power. Now, the pieces that I have left are this x squared, this 7x to the 4th y to the 1st. I'm just going to multiply those together. When I'm multiplying, I need to make sure that I make the same variables multiply together, and I use my exponent rules. X squared times x to the 4th is going to give me x to the 6th. My y to the 1st is going to stay y to the 1st. My 7 stays 7. So my answer is just 7x to the 6th y, where x cannot equal 0 and y cannot equal 0. My next one. I do have some factoring that I need to do here. On my numerator, I have a GCF, so I can pull out 2x, and I'm left with x minus 5. In my denominator, I have a difference of squares. So I have x plus 5 times x minus 5. On my second fraction, there's nothing that I'm going to cancel. However, I am going to go ahead and put this x plus 3 in parentheses so that I remember it's a full binomial. I can't just cancel part of it. I have to cancel the whole thing or nothing. Now I look at my second step, which is to find any excluded values by looking at my denominator and setting that equal to 0. So x plus 5 equals 0, x minus 5 equals 0, and 2x equals 0. Simplify or solve. Guys, I'm getting lazy. You can tell that it's almost 4 o'clock. Yes, I waited till the last minute. Don't judge me. So x equals negative 5, x equals positive 5, and x equals 0. It's not the last minute. I still have like 12 hours before you need this. More than that. Anyway, so now I'm going to do my last step, which is to cancel anything that I can cancel. So I can cancel out x minus 5 and x minus 5. I can also cancel out 2x and 2x. So that just leaves me with x plus 3 over x plus 5. No, I cannot cancel those x's because those are binomials. It's all or nothing. Can't just cancel addition. And then where x cannot equal negative 5, positive 5, or 0. My last problem, I again am going to have to factor. Good thing we love factoring. On my first numerator, I can pull out 3x, and I'm left with x minus 1. On my denominator, that factors into x plus 5 and x minus 1. On my second numerator, that factors into x plus 5, x minus 4, over 3x doesn't factor. I need to find any excluded values. So x plus 5 equals 0, x minus 1 equals 0, and 3x equals 0. Solve. X equals negative 5. X equals positive 1. And x equals 0. Lastly, I need to cancel out anything that is common. So I can cancel out x plus 5s, x minus 1s, and my 3x's. That means that I am simply left with x minus 4, where x cannot equal negative 5, positive 1, or 0. That is the end of the examples for multiplying rational expressions. I'm going to stop the video and upload it because these videos are tough to upload if they go too much longer. And you need to go to the third video for dividing.